Hello everyone, my name is Rajan Lamishane. Today our discussion will be on decision errors and hypothesis testing. So here is the overview of today's topic. So let me ask you, what is hypothesis? When I ask this question, most of most of individuals they answer that it's an educated guess. So when we say educated guess, then what is the educated means? Anything that can be tested or supported with the evidence. So, if you cannot test that guess or a statement, then that is not the hypothesis. So, let me give you three examples here. Example First example shows red is a most favorable color, so it should be used everywhere. Second example, students who attend class do better than students who do not attend class. And the third example, the trend of diabetes is significantly increasing. So, out of these three statements, which statements are the hypotheses? B and C. Here you see that A is just the statement because you cannot test this, and this red is the most favorable color could be just a personal choice. Yes, it's just the statement, and you cannot test this. But for B and C, you can use the data to test these statements. That's why these are called the testable statements, and these testable statements are the hypotheses. So, in general, any claim that can be tested based on some well established rule is called the hypothesis. And according to the American Heritage Dictionary, a tentative explanation for an observation, phenomenon, or scientific problem that can be tested by further investigation is called the hypothesis. Now, why do we need to do the hypothesis testing? There are two types of studies, descriptive and analytical studies. And descriptive studies, they are the background of all analytical studies. And descriptive studies, they only answer the question like who, where, and when. So they only answer the questions who got the disease, when the disease was developed, or uh, where it was developed. So they just show you the trend or the pattern, but they are not there to establish the association or the relationship. And to establish the association and answer the questions like why and how, then we need to do the analytical studies. For all analytical studies, these questions about how and why are answered by using the hypothesis testing. So, hypothesis testing is a validation tool of any experiment, and any result from the experiment it should be supported through some test, thesis testing, because without hypothesis testing, then the result may not be very convincing. And hypothesis testing is a part of inferential statistics. Inferential statistics is about making the decision or conclusion. And hypothesis testing is a, you can think hypothesis testing as a data driven technique, means it requires data to prove or disapprove any claim. And because of this, hypothesis testing is widely used in all evidence based decisions. And remember that hypothesis testing is different from the procedure you do, the clinical procedure. So, in clinical procedure, we implement the technique derived from the hypothesis testing to identify the pattern or to identify the disease. For example, the method of identifying whether any individual is diabetic or not is not a hypothesis because it is just the procedure. Okay, you look at the blood sugar level and other factors, then you decide, okay, this guy has the diabetes. But the idea of defining or categorizing the individual into this diabetes category is based on the previous research where they proved the hypothesis that The blood glucose level beyond the certain value could be the potential risk factor for the diabetes. So, hypothesis testing is performed to establish the relationship between two or more variables. When I say the relationship means we want to see how several predictors they can predict the outcome or the response. And so how do we do that? We can perform the correlation or the regression analysis for that. So here is an example. There is a significant association between diabetes and obesity. So if you want to prove this association, then you need to perform the hypothesis testing. Another reason to perform the hypothesis testing is to justify any claim. So most of the claims they are made on the unknown population parameters like what is the average height of individuals, adult individuals in West Virginia. So at one point we don't know the average height of all individuals in West Virginia. At that time we need to do some kind of estimation by taking the sample from different counties. So, in order to justify the claim, also we perform the hypothesis testing, and some of the statistical tools for that is one sample test on population mean or proportion or variance. And here is also an example. The average weight of each packet of Rara noodle is at least 85 grams. So if usually FDA check the quality of any kind of food, and they are not going to test all the packages, but they will take a random sample of few packages and then they develop the hypothesis to see whether that meets the criteria or not. And they do perform the hypothesis testing to justify the claim made by the manufacturer. Another goal of the hypothesis testing is to make the comparison between two or more groups. So when you have a data from two or more groups, you want to see if there is any difference in averages or proportions exist. And in that case, you can perform the hypothesis testing. Uh, the common statistical tools that are used for this kind of testing are two sample t-test or chi-square test. Here's an example. The odds of developing lung cancer among smokers is higher compared to non-smokers. So this is our one of the hypotheses, and we want to prove or disapprove this hypothesis. Remember that all claims, whenever you are doing the hypothesis testing, all claims they are made on population characteristics or the parameters such as percentage or mean or variance. What does this mean? It means that usually the population characters like the average height of entire US adult or the percentage of smokers among the US adults. So these values usually are unknown, and that's why we need to make the claim on those unknown values. And all these hypotheses they are defined either on the targeted population, which is the generalization case, or the study population, whatever the population you are studying. And remember that claims they are these hypotheses or any claims they are not made on the sample characters or the statistics, because all sample values, when you draw the sample, they are already known. So if you know something, then you don't need to do any claim or any estimation. So hypothesis testing is for the population parameters, not for the sample. The first and most important part in the hypothesis testing is to define a testable hypothesis. So there are two hypotheses we usually need to define: null and alternate or alternative hypothesis. It is very important to know both null and alternative hypotheses when you do the analysis. And when you read the research articles or journals, you usually don't see both null and alternate hypotheses defined in a very technical way. Most people they only define the thesis or the hypothesis, and they assume that the reader is expected to guess the null hypothesis and alternate hypothesis based on the whatever the thesis they define. And researchers they define the hypothesis in a different ways, but most of the hypotheses they are written is either primary or secondary goal of the research. So all hypotheses are based on either primary or the secondary goal of the research. Usually, in most cases, the hypotheses they are written in the abstract or any other section before the method section. And if written right, then hypotheses they are usually written at the beginning and end of the article in the conclusion section. Now, let me show you one example how the hypothesis is written in any research article. Here is the article. I took it from this source here, and you see this highlighted area here. This indicates the hypothesis. And as I already mentioned, the hypothesis is not written very precisely in a technical way, defining both null and alternate hypotheses. But we'll go over those factors in next few slides. How to define the hypothesis in null and alternate scenarios, and even though they are not defined precisely as a null and alternate hypothesis, just reading these statements here, these highlighted statements, you can easily guess what is the null and what is the alternate hypothesis. We'll come back to this point later after we learn a little bit about the null and alternate hypothesis. Now, for convenience, I'm putting some important notations here. You don't need to memorize all of these, but knowing all of these is very useful in doing any kind of analysis. Any data can be represented by X, and mu means the mean from the population, that which is actually unknown, and we don't know the average of the population. Similarly, the sigma is called the standard deviation of the population and usually unknown, and sigma square is the variance. It is the square of the standard deviation, and this is the variance from the population, usually unknown. And x bar is considered the sample mean, and the sample mean is always known because we already have the data from the sample, and sample standard deviation is denoted by lowercase s, and it is also known, and this population proportion, which is usually unknown, is represented as a p, and the counterpart of this population proportion in the sample is called the sample proportion, which is expressed as the percentage, and it is denoted by p hat. And uppercase n indicates the population size and lowercase n indicates the sample size. These are very useful to understand the technical part of the analysis. Now let's discuss how we can define null and alternate hypotheses. Null hypothesis, which can be written as H naught, you can read as H naught, and alternate hypothesis you can read as H1 or HA. They are the technical terms they are used to define the actual hypothesis. So what is null hypothesis? Null hypothesis is a hypothesis we define based on the commonly accepted facts, and uh, in most time we try to disapprove or reject the null hypothesis. Once we reject the null hypothesis, then only our result is significant. The significance of any result is coming after nullifying the null hypothesis. And when you are writing the null hypothesis, understand that this null hypothesis always contains the equality sign. So what does that mean? There are three types of equality sign. Equality means it should contains the equal. There are three types of equality sign: equal, at most, and at least. Okay, this equality equal, same as, or at most, or at least. So these three signs, if any hypothesis contains, any statement contains these three signs, then they are called the null hypothesis. So for example, proportion of diabetic population in the USA is at least 9.4. So this is a claim. Okay, suppose we have a claim which says proportion of diabetes population in the US is at least 9.4%. So this at least indicates that it has equality sign. So it goes into the null hypothesis. Another example, average height of American men is 177 centimeter. This is means it's the same, equal. So it is equal sign. So when you are defining null and alternate hypothesis, it is not based on any claim. Okay, this claim can go anywhere. It can go to the null, it can go to the alternate, but your null hypothesis must have the equality sign. If your claim does not have the equality sign, then it does not go into the null hypothesis. And remember that, as I already mentioned, all claims or hypotheses, they must be defined for the population characters such as population mean or population proportion. Because in most of the medical research, we are mainly interested in average or mean or the proportion. So our null and alternate hypotheses should be based on population mean or the population parameters. Alternate hypothesis is the complementary or opposite to the null hypothesis. And remember that null and alternate hypothesis, they should not be overlapped. They must be non-overlapping parts. And when you reject the null hypothesis, it means you are accepting the alternate hypothesis. Similarly, if you fail to reject the null, means you are rejecting the alternate hypothesis. And as I already mentioned, the result is significant when you reject the null. It means researchers are more interested in alternate hypotheses. When you reject the null, then it goes into the alternate. Theoretically, all alternate hypotheses contain inequality sign, either not equal or more than or less than. So if your null hypothesis is equal, then the alternate will be not equal sign. And if your null hypothesis is at most, then your alternate will be more. And if your null hypothesis is at least, then your alternate hypothesis is less. So you have these three inequality sign in the alternate hypothesis. Now let's see how we define null and alternate based on any claim. So here is a claim. The proportion of diabetic population in the US is at least 9.4%. So it has at least here. At least means it should go to the null hypothesis because at least contains the equality sign. So we can write down the null hypothesis that the proportion is at least 9%, 9.4%. Now the alternate of this one is the opposite of this at least is less than. So your alternate will become this, less than. And when you have alternate hypothesis, it's just one sided. We are just looking at the left side, okay, the left side. You can think is in the real number line, left side contains smaller number, right side contains the bigger number. For example, if you write the numbers here in this line, then you have 1, 2, 3, 4. So it means everything on the left is smaller than the right. So here, if you look at the left side, this alternate is the left side. So it is called one tail or left tail test. Okay, this is one sided or left tail test. Sometimes we call it one tail, one left tail, or one sided, whatever you like to say. So if your alternate hypothesis is less or more, then this is one tail. Look at that. Here we are just looking at the left side because this alternate hypothesis is the left side, so we have a one tail test or the left tail test. Similarly, here is another claim, average height of American men is 177 cm. So this claim, it says is, that's why it has equal sign. This equality, because of this equality, it falls under this null hypothesis. Once if it is a null hypothesis, then the alternate will be the opposite of equal is not equal. So the alternate will be the average height is not equal to 177. When we say not equal to, then we look at the both sides. Remember that not equal means it could be less than 177, it could be more than 177. So we are looking on the both side, and when you have both sides are not equal sign in the alternate hypothesis, it is called the two-tailed test. The general concept of null hypothesis is that when you are dealing with the relationship on the null hypothesis, there is no relationship or there is no association between two or more variables. That is the null hypothesis. Similarly, if you are looking at the difference, then there is no difference, is the null hypothesis. The alternate of the same null is that there is a relationship or association between two or more variables, or there is a difference between groups. So this is the reason when you reject the null, then you fall under this category. Means in order to see the relationship or in order to see the difference between two variables or more variables, you need to reject the null. Remember that your result is only significant when you reject the null. Now let's see how we can define the research claims into the hypothesis. As I already mentioned, we need to define both null and alternate hypotheses in such way that when you reject the null, when you deny the null hypothesis, then the result should be significant. And if the result is not significant, then it doesn't make sense to report any kind of outcome. Now let me show you two examples to define null and alternate hypotheses. In the first example, the research goal is to see whether the drug A has better outcome than drug B or not. Now, when you define null and alternate hypothesis for this research goal, you have to define in such way that when you reject the null, then your outcome will be significant. So, your result is only significant when you see the results from drug A is better than drug B. So to obtain this significance, as I already mentioned, you need to define the null hypothesis in such a way that you should reject that null. So to reject this null, your null hypothesis must be defined as drug A is not better than drug B. Once you reject this one, then you fall into this alternate category, means which is significance case, where it says drug A is better than drug B. And remember that this is a one-tail test because we are just looking at the outcome uh, of drug A, which is better than drug B. Sometimes this could be more or less better, but no matter whether you are taking more or less, it is always one-sided. And if you are saying drug A is more than drug B, then this is one tail or right tail test. And if you are saying drug A, outcome is less than drug B, then it is left tail test. Now, in this scenario, once you reject this null, then only you see this is a significant outcome. Now, let's see another example here. We want to compare the average height of group A is more than B. So in that scenario, it says more than. Here the statement has more than, so this more than must go to the alternate because alternate hypothesis contains inequality sign. So let's define alternate hypothesis that average height of group A is more than group B. Now once you define this alternate hypothesis, then you can define the null. The null will be the opposite of this more than, which is less than or equal to or at most. So the average height of group A is at most of B. So in that scenario, once you reject this null hypothesis, so once you nullify this null hypothesis, then only your result is significant. Means you only see that group A has a higher average compared to group B when you reject this null hypothesis. And this is also one tail test as we are looking at more than, means it's a right tail test. We are just looking at the right side. Now let's see another example also. US Food and Drug Administration wants to test whether the weight of a ramen noodle meets the promised weight of 85 grams or not. So if you want to test this hypothesis, then you have to define the null and alternate hypothesis. So how do you define this null hypothesis? Remember that this result will be significant when you reject the null hypothesis. So here the ramen noodles should exceed 85 grams. So that's what we are looking at. And should exceed means it should be at least 85 grams, because if the weight of the noodle is at least 85 grams, then it meets the criteria. So this at least goes to the null hypothesis. Okay, so the weight of ramen noodle is at least 85 grams, which is null hypothesis. And then your alternate hypothesis is opposite to this at least, which is less than. And this is one tail test, because we are just looking at the less than in alternate hypothesis, and this is left tail test. Now once we reject this null hypothesis, then we can say that if we reject the null hypothesis, this means that we say, okay, the noodles weight does not meet the standard criteria. Now let's discuss about the decision errors, and let's review the empirical decision errors in medical research. So sometimes these are also called the diagnosis errors. There are two types of decision based on diagnosis, whether the decision is correct or wrong. So when do we see the correct decision? True positive or true negative. These two are the correct decisions. Look at this. So here is disease and this is test. Test shows positive and for the person who already have the disease. So that's called the true positive rate. And here tests show negative for the individuals who don't have the disease. So that is called the true negative. Both of these are the correct diagnosis. Now the errors are coming when we have false positive or the false negative. False positive means here the test shows a positive result for those individuals who don't have the disease, and the false negative indicates that the diagnosis shows the negative when the individual has the disease. So these are the two types of errors in the medical research. And remember that you can calculate the sensitivity or specificity based on these errors. Now let's go to the hypothesis testing errors. There are two types of errors when you are dealing with the null and alternate hypotheses. These decision errors, they can be called type 1 error and type 2 error. Type 1 error is very similar to false positive, and it is also called the false positive rate. Here this is null hypothesis, the status of the null. This is true null hypothesis, this is null hypothesis is false. When you say null hypothesis is false, means this is under alternate hypothesis, and then you fail to reject, and this is a reject. So you get the type 1 error when you reject the null hypothesis when it is true. Means when you are rejecting the true null hypothesis here, then you get the type 1 error. Similarly, you get the type 2 error when you fail to reject the null hypothesis when actually it is false. Means when the null hypothesis is false, but you are still not rejecting it, that means it's a type 2 error. Type 2 error is also called the false negative rate. And this 1 minus alpha and 1 minus beta, these are based on the correct decisions. And there is no error, and 1 minus alpha, as we already know, this is the confidence level. If alpha is 5%, if the false positive is 5%, then 1 minus alpha is 95%. Now this 1 minus beta is what we call the power of any test. So we always expect higher power, and we always expect less alpha and beta, or we want less false positive and false negative. We want smaller false positive and smaller false negative rates. Now let's compare these two side by side. So one of them is the diagnosis error and another one is the hypothesis error. Now if we compare both of them, they are very similar. Okay, this is false positive, very similar to alpha. This is a false negative, similar to beta. And then this is 1 minus alpha. 1 minus alpha is specificity. This specificity is similar to 1 minus alpha, and the power here is similar to the sensitivity. That's why sensitivity is also called the empirical power. Now remember that this empirical means this is based on the data you already have. Okay, these are the numbers, okay, from your sample 20, 40, 30, 60, whatever you have. And these sensitivity and specificity are calculated based on the sample values. But these values, this power here, this power or this 1 minus alpha is calculated based on the sampling distribution. Okay, so it is based on some theoretical distribution and it is considered the standard one. That's why these are called the empirical. Okay, so when you calculate the value based on the data, that is called the empirical, what is available to you. So the sensitivity is sometimes called the empirical power, but remember that this is not the actual power. Now, in hypothesis testing, you always need to have some level of significance because hypothesis testing is based on the false positive rate. And here, when you have your analysis is more sensitive or your analysis is more precise when you have less false positive, means less alpha. And in general, alpha we consider 5%. And if you have smaller than 5% alpha, it means you have more powerful analysis. And if it's not given by default, we consider 5% as a level of significance in most of the research design. Another term we used in the hypothesis testing is a test statistic, and usually we don't report the test statistic in any in article or journal because we only see that when we are doing the analysis, and test statistics are the values that define the p-values. And you can think test statistic is a single value that compares the relevant outcome from the sample data to the value from the null distribution, means the distribution of the sample under the null hypothesis. And it compares the sample data with the expected value under the null hypothesis, and we can compute p-value based on this test statistic. And remember that if you have too large or too small test statistic, it means your p-value is very small. And in calculation, you always think this test statistic is a standardized value of your sample statistics, such as sample mean or sample proportion. Another important term we use in hypothesis testing is p-value, and you always see p-value in hypothesis testing. So what is this p-value? So the concept of p-value is somehow a little bit complicated because it is based on the theoretical distribution of sample statistics under the null hypothesis. But in simplest form, you can say that it is the probability of finding the observed value based on the sample we have if the null hypothesis is true. And you can think that if the p-value is very small, that means that an extreme observed outcome that would be very unlikely under the null hypothesis, means that the, because we are dealing with population and we draw a sample, and now we want to see the value from the sample, whether that is a very realistic value or just by chance. Okay, and if p-value is very small, it means that the observed value is very unlikely to see. And in technical way, you can say that if we observed any test statistic beyond the theoretical line, just like this, the boundary line here, okay, then if we find any test statistic value here or here, somewhere in this shaded area, then it means we are rejecting that null hypothesis. And this p-value is always on the extreme sides. Okay, if it is a one-tailed test, it is on one side only. If it is a right tail test, the p-value is the area on the right side. If it is left tail test, it is on the left side. But if it is two tail test, then the p-value will be on both sides. So if your test statistic is on this shaded area of the p-value, then you reject the null hypothesis. So to reject the null hypothesis, your p-value must be less than level of significance or false positive rate alpha. What does that mean? It means that if the chance of observing the outcome based on the sample is less than false positive rate, then we are very less likely to observe that sample. So that sample is just by chance, means we are rejecting the null. And but if p-value is more than or equal to alpha, then we fail to reject the null hypothesis. And as I already mentioned, by default, we usually consider alpha as a 5%. But if you have very sensitive analysis, you don't want many people to get false positive, then you could pick alpha less than 5%, like 1% or 2% too. Now, p-value indicates the statistical significance, means the significance based on the data, how much change is there in the data. And but it does not see, okay, statistical significance does not measure the change in the outcome, actual disease outcome. So to measure the actual disease outcome, there is a concept called the clinical significance. Clinical significance is based on the effect size, which is also called the change, and it observes the effectiveness of the treatment on the patient's diagnostic level. Means, is the treatment effective enough to cause the patient to be normal? If there is significant change in the patient's outcome, not just the data. So clinical significance is not same as the statistical significance, and sometimes you may observe the statistical significance but not the clinical significance, and sometimes you may observe the clinical significance but not the statistical significance. And for clinical significance, there are some techniques, but usually we don't use them. They are not very often used. Jacobson Talks or Gulliksen-Lord-Novick techniques, we use them, and hierarchical linear modeling or HLM is more popular for the clinical significance. As I mentioned, hypothesis testing is a part of the inferential statistics, or inferential statistic means here in we make the decision and we make the conclusion, and it answers the question about how and why. And there are two types of inferential statistics: hypothesis testing, which is based on the p-value, and the confidence interval. And all confidence interval, remember that confidence interval and hypothesis testing are the equivalent concept. And there is no way you can reject the null in hypothesis testing, and then you can fail to reject that in confidence interval. So both of them should give the same outcome. And remember that all claims, they must be made on the population parameters, not in the sample statistic, because sample statistics are already known and it's not wise to estimate something that's already known. Let me just review briefly about the confidence interval, what we did last time. So confidence interval is another the inferential statistics where we draw the inference based on the interval, and this is also called the interval estimation because there are infinitely many values in that interval, and all of those values are the population possible population parameters. and this is equivalent to the hypothesis testing. Now, let me give you brief approach about the power since we already discussed about the decision errors. Now let's discuss about the power a little bit. When we are talking about the power of any test, in the decision error, 1 minus beta is called the power. Now, power is calculated based on several factors. First, it is a sample size. Okay, for larger sample size, you always achieve higher power. If you all other factors are kept same, then for larger sample size, you always achieve the higher power. And the effect size means how much change you expect. If you are if your experiment is expecting a large change or the small change, that standardized change is called the effect size. And how do you see the change? Because before you carry out any research, you look at the other research, past research, and just guess some change. Okay, you are not doing the actual change. Sometimes clinical trials or the pilot studies, they also give you the value of the effect size. In many cases, we find them from the past journals or any research articles. And if the change is very high, okay, if we are expecting very high change after the intervention, then you need a small sample size. But if you are expecting very small change, then we need a large sample size. Another factor that impact the power is the level of significance. If the level of significance increases, then you need smaller sample size. For example, if the level of significance or the false positive rate increase from 5% to 10%, it means that your false positive rate is increased. So you need small sample size to achieve the same power. In order to calculate the power, you need to know which research design you are doing. So there is no one rule fit for all analysis. So power is calculated based on what kind of design you are using. Chi-square test gives different power, t-test gives different power, ANOVA different power, and so on. So it's not just the one rule fits all. Each analysis has different power. That's why power cannot be just explained by using one rule. And why we need the power analysis in the research? Because power analysis is required since we don't want too many data to be collected, because data is expensive and the collection of the data is also cost effective. We just need the optimal amount of the data to be collected. And also, we if you have a small sample size, if your data does not have, if your analysis does not have enough power, then it's very hard to validate or reproduce the result, same result. And if you can't reproduce the result, then your result is not good. And in order to validate and reproduce the same result, you should have the enough power in your analysis. Thank you very much. I'll come with another interesting topic next week. Bye.